Okay, a little bit on environmental factors. If the ceiling height's greater than 8 feet, you should increase your BTU output by 20% from what that previous chart showed. If the insulation's lousy, another 30. And if it's very, very warm, if it always is exceeding 90, another 30. So if we're putting this thing in Arizona, we would do that. Again, we're assuming new construction, good insulation. Remember, we put a good insulation into the basement, if you remember that from Project 2. So none of this applies to you, but you should see that that would happen when you size a room. You have to consider that. You know, a lot of the modern homes now like to have these cathedral ceilings. In the foyer and stuff, and when you see that, you should oversize a little bit by about 20% for a unit in a room like that. Just an example. Here's a quad system. You know, this is right off of their web page. You know, there's the outdoor unit, 4 separate controllers, 4 indoor units. And the only thing that's not shown here is the junction box to take all the piping in for this, but we've got that coming up. But you could also go with something like this with a different vendor here. This one's a Fujitsu. You can see the outdoor unit is a little bit different. This is designed to be mounted on brackets up high. This is designed to be placed on the ground. This recesses into the ceiling, which you can do. You're allowed to do that for this system because we're assuming a new house construction. So you have some control over that with the contractor. You'll notice that this is pushing in one direction. This is probably for a unit sitting close to an outside wall, but you could specify louvers here, multi-directional, if you so choose. You know, and that way you could stick this in the middle of the room. That's allowable. You just have to provide the right set of louvers and make sure that the vendor offers those. Some considerations where you're going to put these in the house. That's the whole point of the project, is I want you to show me where they go, and whether it's a ceiling or a wall unit. You know, what kind of unit are you putting in, and then a cost if you can find it, the size. How many BTUs is that unit putting out? And as I said, each floor is about 1,000 square feet. So, theoretically, you could do this with as few as 2 and as many as 8. And remember, for our house, we have about 5.5 tons for heating and about 3.5 tons for cooling. So that's what's going to guide your sizing and your thinking when you purchase the outdoor unit. You know, it needs to be able to handle those kinds of loads. And I just said by floor, you're talking 2.5 to 3 tons heating capacity per floor, and 1 3/4 to 2 tons for cooling. You know, assuming that you probably are going to have a little overage here. And I keep saying this theoretically thing, but please don't do this. You want more than just 2, but at least on paper it can be done with 2. Although I think it would make for a very miserable house. And why is that? Well, if the bedroom doors are closed at night, that room's not getting any heat or any cooling, so it's going to become very uncomfortable. So, you could only do this with 2 units if you keep all the, essentially take the doors off in all the rooms, and that's not very practical. So you do want more units than just 2. And that's what I said. 2 units just will not do a good job. The utility room and all the bedrooms will become uncomfortable. Port branches is how we connect. Here's a 5-unit example. You can get up to 8 again, so you can go at once. This mounts inside the house, down in your basement. You run your pipes down, and again, it's supply return. So this is a 4-port example. So you have your connects for your supply and return here, and then once these are connected, you can go outside and you can charge the system and get yourself going. But then 2 pipes run out here, so you're only going with 2 pipes and the wires out to the main control box. Here's an example of that 1.5 inch outer diameter, and that's the rubber tube around it. It is self-insulated, but you can just run these through the walls. Bend radius, you need about 4 inches. So when you go around a corner, you want to give yourself about 4 to 5 inches of pipe to allow that to occur, because you can't kink this. If you kink it, it's ruined. You will not get proper flow. And as I said, all the American models are threaded. There's some European ones that are not, but the American ones are all threaded. So stick with that. There's the connection there. You can see it looks very much like a typical pressurized connection. So for your pressure here, and then seal tight here. The system can be charged once installed. You test. What do? Right? You put a partial load on it. You hold that load for, it has to hold for at least 20 minutes with no leakage, to make sure that you don't have any leaks. If the pressure drops off within 20 minutes, you've got to go back through, check all your connections, and see where the leakage occurred. And then once you do that, you can you do a vacuum test on it. It has to hold the vacuum, and if it holds that, then you're good to go, and then you can charge the system. And that is done at the outdoor unit through the exterior connections here. I'm not sure if you talked about those in previous courses, but you will have a pressure tank with a vacuum valve, a pressure gauge valve, and you will be able to test the system. You'll need your flaring tool to flare all the fittings to make sure that they're right, and then if you do that, it should work. Check out the YouTube page. I've got a couple of really good videos. They're do-it-yourself videos, but they show what needs to be done, and they do a nice job showing connecting these pipes up and doing the tests. Poor installation is going to cause you lots of problems. This is pulled from a New England study. I deliberately pulled this one because these are all cold weather units, like the ones you'll be selecting. And what they found was that if you did the job correctly, the superheat, which is the temperature over boiling temperature of the fluid, stays within 5 degrees Fahrenheit. That's correct. The engineer in me appreciates that, right, because you want that to boil at the proper temperature. To do that, you have to have the pressure set right in the system to do that. And it shouldn't vary more than 5 degrees for the boiling temperature, because if it does, then you're going to get short cycling. The system's going to wear itself out very, very quickly. And you find that if you do that, the power usage of the system stays within 110% of rating. It will go over a little bit on a cold day, so it isn't 100%, it's 110. If it's undercharged, then you get up to you get often over 10 degrees of superheat. So what happens is the system overheats, and that usually is caused by your flaring tool was a little old and it wasn't sharp as a connection as you thought it was. Overcharged fluctuates, and your current load is tremendous on the system. You're burning a lot of power. The customer is not going to be happy because you overcharged it. And if you get moisture in the system because the vacuum wasn't applied correctly, you didn't have the system dry before you charged it, you're going to find yourself in all sorts of trouble. What will happen is, again, your current load will go up. Even though the superheat looks okay, what you'll detect it because the rating of the system will be well over the current draw that's recommended, by more than 10%.